Hello everyone and welcome to Diana webinar. My name is Maz and today there is a special webinar about our latest release, Diana 10.3, and we're gonna go through some of the main aspects and new features that we have, but there are tons of them that can be found with more detailed explanation from our reference documentations. During the session, I'm going to mute the microphone just to avoid any background noise, but you are always most welcome to share your comment questions through the chat box, or if you want to have a live chat and discussion, please let me know. I'm going to unmute your microphone. In this webinar, our engineering director, Mr. Ab van den Bos, he's going to help me to be panelist of the parts which are associated with design. So based on his great experience in engineering consultancy, he's going to tell you what are the added values of these new features in 10.3 that you can take benefit of them in your projects. So to get it started, I'm going to divide the presentation into preprocessor, kernel, and the postprocessor. There are different developments that we have. I kind of go through them in a kind of item sequence, and later in the following slides, we go through more insight, giving you more insight and the explanation about them. In the preprocessor, we have done a huge implementation with respect to healing and geometry optimization tools in order to be able to import various type of geometries from other modelers, and could be Revit, could be Rhino, could be AutoCAD, and optimize it and make it fit for finite element modeling geometry in Diana environment. So we have lots of tools for the healing, cleaning, optimization, and also enhancing the quality of the imported bodies. Another implementation that we have is one unit package in order to read, heal, improve, and import the DXF and DWG from AutoCAD. So this is also a very powerful tool that everyone can take benefit of that. If you have some drawings, if you have some sections, if you have some bodies that are already generated with respect to the geometry in AutoCAD. We have extended and enhanced our workflow with respect to some repetitive operations. Therefore, we have introduced a new concept. We call it action dialog box. In this action dialog box, you can repeat the same operation, for instance, assigning a load or changing the properties or modifying the, say, the boundary conditions. You can, or in terms of the modeling, extrusion, copying, generation, you can repeat the operation as many as you want, unless you stop and close the operation. We made the objects that are available in Diana color oriented. So that means, I will explain in the corresponding slides, many things can be identified and assigned with different colors and easily can be traced in the complex geometries. We have incorporated a very interactive and nice wizard for definition of the pile in the latest version of Diana 10.3, and you can take benefit of that in combination with the large models like Pyra Foundations. With respect to TBM tunneling, we incorporated additional features to speed up the setup of the model with respect to definition of the line interface between the segments and along the segments in order to define nonlinear bending or some sort of shearing behavior between the segments. With respect to meshing, we have done not only in the AutoMesher and the implementation of the mesh engine, we have improved and optimized the workflow. We introduced very nice feature, we call it incremental meshing method. And this very useful feature that I will explain later that helps you to speed up your modeling and kind of control on the modification of your geometry and meshing. Model code material library has been extended and made more interactive in terms of the definitions. The function values that we had as a basically the dialog box that we had in terms of definition of some sort of values and corresponding function now became more interactive with some predefined arithmetic functions and other predefined settings. With respect to kernel, we have many developments, very basically like tip of the iceberg. I can just briefly mention here about the new work procedure for definition of the construction stage. This is very in line and very straightforward, especially with the geotechnical applications, in order to easily define the model. In order to easily define the model, control the sequence of construction stage, the active parts, the deactive parts, and also with respect to variation of the water level, change of the phreatic surface. Mixture analysis also, we optimized the implementation that we had in Dana in order to make it more interactive and easy to use by everyone to be able to perform the coupled flow stress analysis. For those who are dealing with the dynamic analysis, we have a new feature that helps to convert the distributed loads to the basic dynamic mass. The hydrostatic load we incorporated with the time function. That means you can now nicely combine with one operation the impounding and dewatering process in time and the impact and effect of that on a hydrostatic load. For embedded element with the bond sleeve, we incorporated this cyclic effect as well. We present the swelling effect, concrete swelling effect, which is based on the alkali aggregate reaction. That's a very nice feature, but you can have that based on one of the subroutines that we integrated in the program, so you can take benefit of that to see this anisotropy behavior of the model. And the last three items are very nice and important and effective that my colleague Ab going to talk about them. One of them is the assessment of the bridge based on the model code. This is very important based on the existing bridges, assessment of them if they're complying with the new traffic load, the recommendation in the model code. The cross-section design check as well about the moment capacity, and a strain reduction analysis. This is in conjunction with the total strain crack model that basically lets you know the conservative or basically the capacity, remaining capacity in your model, the damage model, and also the progressive failure that you may anticipate from one of your concrete segments. So I'm going to explain about these three parts later in this webinar. And also with respect to the post-processing, we have enhanced the speed of the data management, the representation of them, plus for different type of output, we have added additional, output parameters like over-consolidation ratio, maximum shear strain, hydraulic gradient, and so on and so forth, that you can find more in detail from our documentation, but also I touch bases of some of them during this webinar. So let's start with the healing process. We have incorporated one of the latest technology and the solutions that offered in conjunction with Parasolid, this body shop. and we incorporated that in Dana along with our Parasolid engine for modeling to be compatible and very efficient and optimized in terms of the model definition and workability in the Dana environment, in order to clean and heal and optimize the geometry, which they have some inconsistency with respect to the geometry, with respect to their topology, with respect to the coincident edges, nodes, or flashover edges, small faces, and so on and so forth. So there are many tolerance items and control panels are available based on the different objects that we have, and you can control them in order to be identified and healed and proceed with the whole modeling aspects in Dana. For AutoCAD or import of DXF and DWG, so similar to other features that we have STEP, IGS, DXF, DWG, and IFC. You can import DXF and DWG, and our import feature covers all the earlier version that we had from the release of 2014 or 14 up to now. And also all the geometry entities can be imported. However, you need to be aware that if you have some entities like text, hatch, light, these are the things that are not imported in your Dana model, because they don't have any structural value. They are just drawing and explanation entities. Another thing that you have is the layers in AutoCAD model, and you can import AutoCAD layers based on the various shapes that we have and under the different sets, so you can activate and deactivate all those things in a sequence. Some of the recommendations that you may need to consider when you're importing CAD is the definition of the unit, so the unit that the model is defined and the hosting unit in Dana that you want to import. And also make sure that your size of the model is matching with the bounding box of the Parasolid that you import in Dana. So these are some tips that you may need to consider when you want to bring and import some DXF or DWG into the Dana. With respect to checking the bodies, when you import, we have added additional features that can be easily identified. So we have a short edge, sliver face, small face, knife edge, knife vertices, and tolerant entities that based on the selected items, you can choose Dana to go through whole your model and automatically flags and identifies based on one of these problem that you may have in your model, and you can identify, and based on those issues you can decide, I'm going to do optimization, I'm going to do cleaning, or I'm going to define a right strategy to do healing process in my model. So with respect to repetitive operation, as I mentioned, we have a new action box. So when you select one operation in terms of the creation or modification or adding, removing, all those things, there is one dialog box opens in your Dana environment, and you can repeat this process by clicking on apply, and when the operation is over and you want to go for another type of operation, you can simply click on close. So this way you don't need to always go and open and from the main menu recall the same operation and the information that you want to do. So this is very nice and helps you to speed up your modeling in your process. The object-oriented color control, as I mentioned earlier, it is very nice because you can assign different colors to different types of shapes that we have. For instance, we have a cylinder, we have a cube, we have a face, we have a face. So each of these, there are different entities, therefore they can be represented based on different colors. You can assign the material, and the color are representing the material. Here, for instance, the two sheets are carrying the same property, same material, so you can see both of them are gray, but the cube and the cylinder are carrying different material properties. The type of body, because the cylinder and cube, both of them are solid, but these two sheets are kind of face, so you can see, you can identify in your model what are the objects that you have, all the solids, all the edges, all the faces. You can identify with color, and this is a very powerful feature. Similarly, at the mesh level, you can identify them by the element set. So you have different element set per geometry, per shape that you had. You can also show the different colors for the material, similar to the at the geometry level. And this is very nice because you can identify various element topologies. So it's kind of a wedge, tetrahedron, brick, or hexa. You can easily identify, and this helps you that if you're doing some sort of nonlinear analysis and some localization is occurring in your model, you can identify if this is because of the bad shape element or this is because of the real failure at the material level. So you can easily identify what type of elements you have in your model with the color representation. Incremental meshing is becoming very powerful and very useful in order to save time, especially if you have a complex model, complex geometry, and you need to do some modification at certain part or certain corner or certain segments of your model. In that case, when you want to remesh the model and update the information before the analysis, then automatically recognizes only the part that is modified. Therefore, it doesn't touch the whole model in terms of the meshing. It only remeshes the modified part and adjacent segments or geometries. And this is very powerful in terms of saving your time rather than going through the whole remeshing the whole model. It only remeshes the modified part at geometry level. The model code material input, this is very nice feature because we defined the safety factor earlier at the material level. So you could have in the model code, you could define some factor of safety, and all those factors of safety were implying over the corresponding material properties. But now, if you have a complex model, you have different types of material properties, we allow our user to define this safety factor at the model level. Therefore, the whole these factor of safety are applied to all the model codes that we have listed here, and also these parameters also affects the associated parts with respect to total strain, shrinkage creep, and Young hardening type of analysis, and we incorporated additional information in the model code with respect to these behaviors. So this factor of safety is very important. So for ease of use, you can define that at the model definition, and you can easily set up those parameters, the factor of safety here, and then this implies over the whole model. Moreover, for the materials which are time or maturity dependent, we have this icon here. So based on the selective model code, you can click on this icon and you can see the evolution of these material properties in maturity or in time or whatever we have in terms of these reference input in a corresponding dialog box. And this is very nice and interactive in terms of checking if this is exactly what you want to consider in your model or no. Earlier time when we were doing heat of hydration analysis, we were defining adiabatic curve either based on the user input or based on the degree of reaction. But now we also made it available to consider that based on the element age, and this helps to get the similar input as what, for instance, some of the model codes are recommending. So in some type of analysis, you may have this type of S-curve, but also in some model codes, they don't consider this S-curve and they start from 0. So in both cases, now Dayana offers solution for you, and you can use this definition in adiabatic curve and you can assign it to your model for better or more accurate analysis with reference to the model code or the analysis that you want to consider. The generation of the function, as I mentioned, now you can write your own function here in the corresponding expression, corresponding input file. There are arithmetic functions are available. Different type of units can be considered. And also there are some predefined functions that you can directly define them and perform some sort of define the corresponding input and use that in the analysis and assign it to your load, boundary conditions, or other type of variables that you have. This is very useful. It will speed up your process. So rather than defining all these values in Excel, copy, paste, you can directly, if you know the, for instance, sequence of your impact or the loading sequence or all those things, you can consider the function and then, for instance, program automatically generates all the required data for you. For Pile Foundation, we have delivered a very unique solution that I can proudly say this is a very intuitive and very unique solution compared to any other available solution. So in this dialog box, it's a kind of wizard. You define what type of mechanism you want to consider for your pile. Is it axial pile? Is it bending pile? There are some predefined geometry setup like a circular, rectangular, tube, and based on that you define the minimum geometry parameter like the diameter or the thickness or the width and height. And then everything is automatically driven by Dayana with respect to associated parameters. Then with respect to information for the pile, it's nicely you set up with the elastic parameters. Then you go for the shaft friction. And also if you're dealing with the pile tip, you can consider this pile failure behavior either based on diagram or based on alt failure. And the variation of the shaft friction in depth can be calculated automatically with Dayana. So there is an R factor that automatically calculates the variation of the material property and impact and effect of that on the shaft friction. So here you can see any complex models can be easily selected based on the different pile sets. So you can group the piles, you can get the output separately, you can manipulate them separately, assign the property to them, you can use the drag and drop into those sets. So it's very intuitive, very useful, and in terms of the output it's very intuitive. All the information can be driven in a push of a button and you can take benefit of that with respect to your large model. No need to mention that we are the first group who delivered this concept as an embedded element. That means we are using the same technique in pile definition, and you don't need to have any nodal connectivity when you're defining your pile with respect to the soil model. So here you can see the block of the soil, how they are coarse, but the piles are easily going through without any nodal connectivity. So for tunnel lining, TBM, I think up to now you already maybe guessed, but we emphasized a lot with respect to ease of the workflow and enhancing the workflow for geotechnical applications. So you can see this implementation and illustration in these slides, maybe more towards some geotechnical and tunneling applications, but I'm sure you can take benefit of that in other aspects and other applications as well. So when we are dealing with the TBM tunneling, one of the key factors is the stability of the tunnel segments, how they are aligned in a ring and how they're interacting with the next ring or adjacent rings in the model. So one of the characteristics that we have, because we modeled this lining based on the shell elements, and we simulate this interaction based on the line interface. This line interface, we introduce either Coulomb friction or in combination with the Janssen law to capture nonlinear bending. In terms of the sequence of the modeling, you can easily define this sequence of the line interface between in the ring, so to model the shear dowels, and also the adjacent one between the rings. And further on, you can consider the interface between your liner and the rock mass. So all those two different layers of the interface. So you have a uniform interface between your lining and the rock mass, and also a series of line interface between the tunnel segments and adjacent rings. So you can take benefit of these easy setup of the interfaces in the model, and basically use that in your, for instance, TBM, tunneling, NATM, even solution that you have if you want to model some sort of yielding element in your liners. So you can easily use the same concept in NATM as well. As I mentioned, we came with a very interactive, user-friendly, and streamlined workflow, and we call it stage construction analysis, that helps you to define the impact or effect of the variation of the water in a construction stage in Dana. So this is important because the water management is always one of the key factors in geotechnical applications, and the user need to have the freedom of introducing this variation of the water level or the different phreatic surfaces. So it should be easy to set that up and easy to change and combine that with other stress analysis. So these type of things could be when there is no water level is influential, when there is a water level and we are just simply dealing with dry density and saturated density, then there is a water level, we are talking about steady state, and when there is a water level and change of water level, and we are talking about transient analysis. So all those sequences can be easily and nicely introduced and processed in this new stage construction analysis. That there are a couple of new tutorials are available in our website. You can easily refer to them, and we can always help you to address your possible questions. So here is a simple cut and cover tunnel, the state of initialization, the gradient of the hydraulic gradients, the water levels, and the pore pressures are in the first phase are illustrated here in this column. Then we have excavation process, including dewatering, so you can see the water level is changing. And in the next stage, we are activating our structural tunnel or the culvert. And then we see what is the stress variation by adding the extra weight on the model. And then we cover our, top of the tunnel and start to release the water. So you can see this process in this direction in terms of the construction stage, and in this direction in terms of different impact and results in Dana. Very useful tool, very easy to set up, and we can illustrate that by means of different type of tutorials that we have, and you can easily find your way and acknowledge this new improvement that we have done, especially for our clients and prospects who are involved with geotechnical applications. The mixture analysis, as I mentioned, is one of the powerful capabilities of Dana, but we made it very user-friendly and more interactive, and also because when we are going for a fully coupled analysis, that's PU formulation, your pore pressure and the displacement, that's a fully coupled analysis, you are required to define more parameters at the material level. Therefore, in order to make manage the project and control the input parameters, when you define a new project, we have made a new setup, and that's mixture analysis. So when you click on this, those additional parameters become active. Therefore, you're required to put different, say, input with respect to porosity, the saturation, and information associated with respect to the water and the porosity and the void in the soil. So, as I mentioned, so when you change the water level, this change in the water is causing some sort of deformation. With the deformation, again, you have some sort of extra impact and effect on the porosity, and the water will be seeping in different manner. So it is a fully coupled approach, and it's a very nice solution that you can incorporate that with, for instance, embankment, levees, and consolidation. One of the powerful features that we offer here, because Dana is one of the pioneers in terms of delivering solution for all types of dams and dikes. And this was always one of the challenges, and now we have a solution, and we present it proudly with respect to variation of the hydrostatic pressure in time. So that means you can mimic the whole process of, as I mentioned, impounding and rapid drawdown, or increasing or variation of water level in season, in time. So you can consider at the same time the hydrostatic impact and effect of those aspects on your model. And with respect to distribution of the uniform say load, you can, when you perform dynamic analysis, you can transfer that to dynamic mass, and you can incorporate it in one of the directions or in all directions, and use it in conjunction with the mass of the model. So this is when you want to basically transfer one of the static to the dynamic type of a static model to dynamic model. You can use and take benefit of this feature in Diana. Concrete swelling, because of its very common issue with, say, people who are dealing with the concrete, and the concrete is subject to some sort of water and some sort of seeping and impact and influence of the alkali aggregate reaction, or the cement or chemical effect from the cement, and introducing some sort of anisotropy strain or the deformation in the model. So we have incorporated this user-supplied subroutine, but with the interactive user interface, to mimic this behavior, and as a result you can get the rate of swelling strain in the model as the model goes through the time, or say process of the transient analysis. Further on, with respect to our embedded element and elements, especially with some sort of energy dependency, we incorporated bond slip effect as well. Therefore, now you can use bond slip reinforcement not only for the von Mises plasticity, also for Minigoto Pinto, Montinuti, based on the Japanese Society of Civil Engineering plasticity, and Dodd Ristretto, regarding the combination of these two effects in the model, so embedded element and also bond slip effect. I touch basis of two slides, and then I hand over the presentation to Ab. The first one is now it's possible to define cylindrical coordinate system independently for different part of your model in order to extract the results based on the axial and radial and basically theta. So all those information can be driven now based on the reference coordinate system that you define at the geometry level to different parts of your model, and you can extract the results independently in the model. And the next one is the embedded animation generator. This is also a very nice and powerful feature that helps you to generate the animation not only for one case, you can also consider for all the results history that you have. And this function can go along with all type of outputs that we have, could be load step or time steps. And you can create the animation, you can store the pictures of different time steps, and you can control the frames and the cycle of them if you want to present it and basically show it to your clients. So Ab, I'm going to make you presenter. If you have your presentation ready.
I want to explain a little bit over the new feature of assessment of bridges. And where there is assessment of bridges, you could also read assessment of structures, because we incorporated first the main thing for bridges, because all over the world authorities are dealing with bridges which are overloaded by traffic increase and or deterioration of materials. But the same method that I'm going to describe here can also be used for normal structures, non-bridges. So we made a new calculation analysis feature that is star design. And in design, you can implement cross-sectional analysis based on a nonlinear analysis to calculate the capacity. And for bridges, you can add loads like UDL loads or a traffic set of loads where you have the actions. And if you combine the actions against the resistance, you can have a unity check. So it's an extended functionality because all the loads are based on the Eurocode description of UDLs and tandem traffic. And on top of that, with this new feature, we can calculate all the bending moments and shear forces, and we can average them in a certain way I'm going to describe, and we can shift them according to the Eurocode. The models can be made of volume elements, as you can see here on the left side, solid element model, or they can be as shells. If we have a solid element model, then we add a composed sheet, and all the stresses will be integrated and plotted, projected on the composed element, and you will get the distributed moments and forces. So that's a very handy way of coming from stresses to bending moments and shear forces. We can add grids that can be straight or they can be curved if the bottom is curved, and they are taken into account in the cross-sectional analysis. So the capacity. Further on, you can checkbox a grid to have the minimum requirement of the area for that grid. So you can do it in two ways, either add a grid as a capacity or let Diana do a calculation of how much area of reinforcement is needed. If you go to the next slide, there we see the capacity displayed, where Diana can have calculate the bending moments in two directions. So we have the plus and minus and the X and Y direction. Furthermore, we can show as a model data also the here on the left side, it's very small, the compressive length, so the XU, the height of the compressive zone, and we can show the averaged capacity of the bending moments. So that is a model data based on the input of the thickness of the structure, the material to the concrete, and the amount of reinforcement you have. And you can do this cross-sectional analysis in either two ways, with or without the tension capacity of the concrete. According to the model code, you leave out the tension capacity, but if you have a hybrid structure like added steel fibers, then you can turn the concrete tension on, and it will take that also into account. It is important to highlight the averaging item, because if we look at the bending moment, for instance, in X direction, then we may average in the Y direction over a length of 2 times the height, 2 times the level arm. And you can change this factor of 2 if you would like, but the default setting is 2. And for the shear forces, we may spread the shear forces in each integration point over 4 times the height of the structure. So that is in the perpendicular direction of the action. In the direction of the action, the Eurocode prescribes that we need to shift the bending moments over a length of the height of the structure. So for instance, this bending moment will be shifted to the left and to the right as the height of the structure. It's done fully automatic. The loads acting on your structure are divided now in permanent loads, variable loads, unique loads, and traffic loads. So the permanent loads will be always there. For instance, the dead weight of your structure, the asphalt layer on top, and all these kind of loads. They commonly have 2 sets. It's on or off, so favorable or unfavorable. If they work favorable, then we need to multiply them with the safety factor, and if they are unfavorable, we need to multiply them with a higher safety factor. So if they are favorable, for instance, times 0.9, 90%, and if they are unfavorable, then times 1.2. This works for all the permanent loads in the model. Then we have variable loads where they can be on your model or not. So for instance, common traffic UDL or another variable load. You also think of buildings or other structures where the load can be on or off. And Diana is adding the load cases automatically with the on or off check. Unique loads are another kind of variable loads, but they will be excluded from each other. Then we have traffic loads, and that can be traffic sets. So according to the Eurocode, you have a lane where the trucks are driving, and each lane consists of 4 pressure rectangles, and those pressure rectangles will be shifted over your constructions in small steps, and each step of that traffic set will add a load case to your analysis. Furthermore, these traffic loads can be combined to sets because on many highways with multiple lanes, for instance, here on the right side, you see set 1, 2, 3. It consists of 3 lanes where we have 1 lane that has the biggest load, the higher axle load, another lane 2/3, and another one 1/3. So that is one set of traffic. 1 higher loaded lane, less loaded, and again less loaded. But you also need to verify a different type, that the middle lane is the higher load. And the last one is the 3-to-1, where the right lane is the higher load. So combining those traffic sets, you can literally have all the combinations you will need to check your construction for. And with all those combinations, if you have added them to the analysis, you can imagine that you have a lot of combinations, and we need to make envelopes of that to have the normative loading. The normative loading is remembered by the program. Diana offers you the feature to show the normative position of those tandem traffic loads. So for instance, in this case, the higher traffic lane is loaded here, and the two lower traffic lanes are loaded here. And it gives a normative bending moment as prescribed in monitor. If you have a sectional approach, like in this picture, we have a compression in the concrete, a tension in the steel, and we can check on or off the tension in the concrete if you have steel fibers or another type of tension capacity. And what is done is that we increase the curvature of the model in small steps. And with each curvature, we take equilibrium with the compression and the tension forces. And if we have equilibrium, we are able to calculate the bending moment. Then we increase the curvature again, and we get a new bending moment that probably is increasing onto a certain curvature where we find a maximum bending moment, then it's lowering again. That maximum bending moment is stored, and if we have that maximum bending moment and we get the action from all the load cases that are prescribed before in this presentation, then we can divide them on each other and we get a unity check. If the unity check is lower than 1, it is okay. If it's higher, we need to add either concrete construction height or extra reinforcement, or in case of an existing viaduct, we can add, for instance, carbon layers or something else to strengthen the construction. So on this slide, you are able to see the unity check where the acting load is divided by the resistance capacity. And that can be either the bending moments or the shear forces. So in this way, we can automatically check a complete bridge for the Eurocode load combinations in a very handy manner. But this way of analyzing can be also projected on other type of constructions. Then the last feature we added in Diana is the strength reduction analysis for a total strain crack model. The strength reduction analysis is already well known in the geotechnical approaches, where it's called the phi-C reduction. We reduce the phi and the cohesion, and then a failure plane, slide plane can occur. It's a kind of safety. In the total strain crack model, we implemented it because if we look at a type of failures, you can have, for instance, a bending failure in this beam where we have two supports over here, and a loading over there and over there. And depending on the amount of bending reinforcement, you will get first bending cracks to a certain level. And if that is your load level for the ULS, you can say, well, my construction is safe, but you are not sure whether you're very close to a shear failure or not. By adding the strength reduction analysis to your ULS load, Diana will reduce the tensile strength and or the compressive strength in the model in steps. And at each reduction level, we get a new state of equilibrium with probably wider cracks and maybe a shifting of the crack from a bending moment to a shear crack. And with this approach, we can see this factor of safety between your ULS state of cracking and your ultimate failure when the concrete material is a little bit less than expected in reality. So Maas, these are the last slides. I would like to hand over the presentation to you.
At this moment, I would like to thank you all for attending this session, and I hope you could find it informative. Thank you very much and have a very good day.